these days people are using to develop applications, different types of applications, web applications or Windows applications, or even in mobile computing, it is used a lot. Not exactly Java, but something like Android they use for developing mobile applications.
Okay.
So Java is a high-level programming language, and it is object-oriented language, unlike C, unlike Pascal, or unlike Fortran. So this is a object-oriented programming language. Are you hearing me?
Yes, sorry, it's a bit noisy in the background because my wife's going to use
Yes.
So sometimes I go on mute. I always do that. Don't worry.
Yes. See, if you're using, computer speaker, it echoes. If you don't use computer speaker, if you use headphones, in that case, you don't have this echoing problem.
Yeah, I'll.
You can mute yourself. If you question, you can just type here. I'll be responding to that. You can mute yourself. So with that, this echoing problem we don't have.
Yeah. Okay. Not to worry.
Yeah. So Java is a high-level programming language like C or Pascal or say C++ or C#. So it's a very high-level programming language. Even C cannot be called as a high-level programming language because using C, you can actually develop, system programming. You can do system programming with using the C language. But Java mostly we use for developing very high-level applications. So mostly business-oriented applications you can develop using Java. Okay. It may be a desktop application, or it is a console application, or it can be a web application, or a web service, or it may be web API. Okay, so or it sometimes you will develop applications for particular devices also, something similar to embedded systems application, but you need to have JRE in that. If you have JRE, Java Runtime Environment, you can develop applications for devices also. So virtually any kind of application you can develop using Java programming language. Java got developed, the very first version of Java was introduced in 1995. Very first version of Java came into existence in 1995. So Java language was developed by James Gosling and Patrick Norton. These two people together initially they developed Java language. Initially Java got developed for TVs. So initially for TV purpose they developed Java language. That's for smart TVs. But in those days, around 22 years before, we did not have actually smart TVs. So this much smartness we could not see in those days. So it was of no use. Okay, so then after that, after seeing the growth of web actually, they have started developing modules for web. So that was J2EE. So initially, the very first version of Java got released in 1995. It was Java 1.0. That was the very first version as far as Java is concerned. In fact, Java was initially called as Oak, O-A-K. So it was a tree name. So, but later on that was changed to Java. Generally, Java meaning is it is nothing but liquid. It can take the shape of the container. It can take the shape of the container. Since it can take the shape of the container, it means you can develop any kind of application using Java. So that's the reason they named it as Java. Okay, so to develop Java-based applications, you require JDK, and to execute Java applications, you require JRE. JDK stands for Java Development Kit. So using Java Development Kit, we develop Java applications. And to execute Java applications, we require JRE, which is called as Java Runtime Environment. Now let me tell you. So here you have two parts. One is JDK, the other one is JRE. So using JDK, what exactly we do here is write code. Then after that we need to translate. Then here you get bytecode file. We get here bytecode file, that is nothing but Java compiled. So first of all, you write source code using Java language. After that, with the help of the Java compiler, we translate. After that, we get the bytecode file. So this happens in the case of development environment. Now suppose you want to execute the bytecode. For that, we require the bytecode followed by here Java interpreter. Okay, then it is going to be developing for us machine code. Okay, so initially what we do, we write source code, then we translate. Translation is nothing but here compilation. We compile Java source code into bytecode. So once bytecode is created, to execute it, you require here Java interpreter. With the help of Java interpreter, we convert into machine code. Then on the machine, it can be getting executed. Okay, so if you talk about any other language like C or C++ or you take Pascal, so in that case, when you write code, when you compile, you get straight away object file or exe file. Straight away the exe file is generated or object file is generated. So if you create an exe file or object file, they become machine dependent very much. You develop for Windows, it can be working only with Windows. In the case of C, C++, Pascal. Similarly, you may be writing code on Linux, so it can be working with only Linux. If you write for Macintosh, it can work only with the Macintosh. But as far as Java is concerned, you can develop in Windows platform the Java application, you can translate, you can get bytecode file under Windows platform. The same code you can take and you can execute on the Linux machine or on the Mac. So that is the power of Java language. So Java is what here? It's a portable language. Whatever Java applications you develop, they are portable. On one platform you can develop and on the other platform you can actually execute it. So like this, we have the portability. That's why Java has become famous. Write only once code but execute number of times on different OS on different platforms. So that is basically a portable code you develop using Java programming language. So this is the very first thing we discuss about Java. Otherwise, you have so many languages. Why you have to go for Java? Because you have your portability. As far as Java is concerned, you can develop portable code, so that code can be executed on different operating systems and on different machines. Provided that on the target machine, we have Java interpreter. If there is Java interpreter, in such case only, you can execute. So you write code once, then you translate. After that, you get the bytecode file. So this bytecode file you can send to the target machine or target computer. So there you require JRE, Java Runtime Environment. With the help of that, the bytecode is interpreted and it is going to be executed on the machine. So like this, we work with Java. So here we call it as JDK. Here it is Java Development Kit. With the help of that, you write code, then you translate or compile into bytecode file. But whenever we talk about execution, here you require JRE. Java Runtime Environment is required. There it can be getting executed. Okay, so to develop Java applications and to execute Java applications, we need these two. One is JDK, other one is JRE. So what constitutes in JDK? See. So when we talk about JDK, here you have compiler. Java compiler we have. Also, we have debugger. Okay. Similarly, we have jar tool. So these three tools are very, very important. Using compiler, you can translate into, say, bytecode, and with the help of debugger, you can be debugging the Java code. Then with the help of jar file, you can be archiving it or you can compress. You can be compressing the files into smaller size. So these two are very, very important. Apart from this, you have many other things like Java doc you have. With the help of Java doc, you can create actually documentation for the code what you write. So these come under JDK, under Java Development Kit. And whenever we talk about JRE, here you have, first thing is Java Interpreter. We have here Java Interpreter. The next one is here JVM, we call it as Java Virtual Machine. So these two are important as far as JRE is concerned. So using JDK, you develop application and ultimately you create the bytecode file. So that file will be executed in the target computer or target machine with the help of the JRE. It constitutes here Java interpreter as well as JVM. So with the help of these, we can execute. Fine. So these are basically how we develop Java applications and how we execute. These two terms we talk, we discuss a lot about these things, JDK and JRE. You write code, you translate, you get the bytecode file. Okay, once you get the bytecode file, that bytecode file can be ported to target computer. So in the target computer, with the help of the JRE, Java runtime environment, we execute the application. So whatever application you develop, it's basically bytecode files only. It may be one file or it may be more than one file, but all of them are going to be bytecode files. So with the help of JDK, we do it. And using JRE, what you do exactly, you execute the application. So here, since Java is platform independent, instead of creating straight away exe file, it's creating for us a bytecode file. We call it as class file or bytecode file. That file will be executed in the runtime environment with the help of the Java interpreter and JVM, with the help of Java virtual machine. Okay, to develop Java applications, we require some IDE. IDE stands for Integrated Development Environment, which is called as here Eclipse. We call it as here Eclipse. I use actually this particular tool to develop application. Eclipse is actually IDE, Interactive Development Environment or Integrated Development Environment. Using that, I develop Java applications. So most of the work manually we do, it is accomplished with the help of this particular tool. So it automates certain things, with that our productivity increases. So using Eclipse tool, I develop Java applications. Be it is a console application or a Windows application or a web application, I prefer to use Eclipse. With the help of Eclipse, I develop Java applications. So therefore, this Eclipse is what? It is IDE, Integrated Development Environment for developing Java applications. So once you install the Eclipse, you can start developing the Java applications. Also, you need to install the JDK, the JRE. So you need to download Java, tool totally, Java development kit as well as Java runtime environment. You need to install in your system. After that, you have to install Eclipse, then you can start developing Java applications. Okay, so this is related to developing applications and what is JDK, what is JRE. We try to understand that. Now the question is, what basically Java is? Java is a programming language. It's a high-level programming language. So you write in English. Whatever you write, you are going to write in English in Java. Okay. Second thing is, Java is a case-sensitive programming language like C, C++, JavaScript, okay, C#. So this is what exactly it is, a case-sensitive programming language. It does differentiate between uppercase and lowercase. It's going to be differentiating between the uppercase and lowercase. So Java is actually a high-level programming language which is case-sensitive. And second thing is, it is OOPS, object-oriented programming. So for developing object-oriented programming, to develop actually the classes and objects, we use it. So here, whatever code you write, it's going to be in terms of classes and objects. So with that only, we are going to be doing it. A class can be treated as a module. You can think it as a module. You can be developing various modules. They can be called as classes, and using those classes, you can create objects. So Java is what here? It's object-oriented programming language. So I write it as object-oriented. Next thing is, it is case-sensitive. It does differentiate between uppercase and lowercase. Whenever you write code, it's going to be differentiating between uppercase and lowercase. And it is what? Compiler. It's a compiler and it is an interpreter also. So whenever you develop an application, at that time it performs compiler, like it works like a compiler. But whenever you execute, at that time it's going to be working as an interpreter. So like an interpreter, it's going to be working. Then here it is actually a robust. This is really a robust language, and other thing is it is safe and secure. Okay, so whatever code you write with the Java, so the Java code is secured That means whenever you write any program, the program has certain boundaries. Boundaries in the sense every program has its own data and it has its own commands. So whenever you write any Java program, your data is secured. No external application can access your data, or your application cannot be interfering with any other application. So this can be called as here safe. Whatever code you write, that cannot be destroyed by any other application. If you may be having many other applications also simultaneously running in your system, they cannot actually invade your code, they cannot invade your Java program data. So that's why we call it as safe and secure. So it's both safe as well as secure. Okay, then one more thing is you can develop distributed applications with the help of the Java. You can develop distributed applications. So distributed means something like web applications, or it may be SA servers. So those can be called as distributed applications. So using Java, you can develop distributed applications. So these are few buzzwords. With the help of that, you can describe what Java is basically. It's object oriented, it's case sensitive, it's a compiler. Okay, so it's compiler, and other thing is it is a interpreter, then it's robust, safe and secure, distributed. So these are the words we use for, to describe the Java language. So as I told you, Java is object oriented. You need to write classes, and using classes you can be defining objects. One object can be talking to another object as far as Java is concerned. An object can pass message to another object. It is something like an office. When you take an office, number of people they work in the office. So each and every person has certain role. So as per that role only, they are going to work. In the same way, you need to design a Java program. You may be having number of classes. Each and every class has a predefined task assigned to it. So it has to perform only that particular thing. In that way, you can actually develop this object-oriented programming. So even using C, you can develop. Okay, but there you have to put a lot of effort. But in the Java, you have certain inbuilt features. With the help of that, very quickly you can develop the object-oriented programming. So using here the Eclipse, you can develop Java applications. Philip, any questions?
No, I'm fine. I'm just listening.
Okay. Yes. See, whenever you talk about any programming language, whatever language it may be C, maybe C++, it may be Java, we use tokens. Tokens are basically entities. Using them, you can write the sentences. In English, we use parts of speech like noun, pronoun, verb, adverb. With the help of that, we can form sentences. So in the Java program also, we use tokens. With the help of that, you can write statements. In Java program, we can write statements with the help of the tokens. The tokens can be categorized as, say, keywords. Okay, then we say identifiers. Then we have operators. One more thing is we have separators. Then one more thing is constants. So these are normally called as tokens. So using these tokens, we write the statements in Java language. It's not only with Java, with any language, you have to follow same thing. So these are nothing but keywords, identifiers, operators, and separators and constants. And to make them, we can use Ascii Character Set. With the help of Ascii Character Set, we can write those. So Ascii Character Set, it constitutes here, say something like digits 0 to 9, then uppercase alphabets, lowercase alphabets, then you have punctuation symbol, operators. So with the help of those, you normally write the here tokens. Even to write tokens, you have to follow certain syntax rules. With that you can do it. A keyword is nothing but is a reserved word for its intended purpose you have to use. Something like int or float or say while. These can be called as keywords. Already in the language there is a definition for these keywords. Okay, so for their intended purpose you must use these keywords. Int, float, while, do while. There are so many number of keywords we have actually. For their intended purpose you have to use. If you violate that, if you are trying to use for your own purpose, definitely it's going to be error. So language does not accept. Compiler cannot compile such statements. So that can be called as compile time error in that case. So keywords have predefined meaning. For that purpose you have to use. Keywords you can compare roughly in English something like with helping verbs is, was, has, have. You have such verbs. For their intended purpose only you have to use them. So in the same way, whatever keywords you have for their intended purpose, you must use it. Similarly, we have here identifiers. Identifiers are nothing but user created ones. Whatever user is creating, that can be called as identifier. It can be a class name, it can be a method name, it can be a variable name. Okay, so it can be an interface name. So like this, whatever you define, they can be called as here identifiers. Whatever user is defining, that can be called as identifier. In the case of identifiers, you have to follow certain rules. Very first letter of the identifier must be an alphabet, followed by you can have a digit or underscore other alphabets. So the very first character or very first letter must be an alphabet, followed by you can have an underscore, you can have a digit, or you can have actually another alphabet. There is one more exception, even underscore can be treated as alphabet. So therefore, an identifier can be started with an identifier underscore, followed by you can have digits or you can have other alphabets. So like this, you have to follow certain rules as far as identifiers are concerned. For example, I want to declare some simple interest. So I can write here simple interest. In this way, I can write it. So there is no space between simple and interest. But normally, whenever we type and somebody says simple interest, we try to give a space between simple and interest. So if you try to provide space like that, it's illegal there. So without putting space, you need to write. Okay, simple interest 100 I may write. Suppose if I try to write 100 simple interest, this is illegal. Okay, reason I'm starting this with the digit. This is not acceptable. But if we put like this underscore followed by 100 simple interest, this is a valid one. This is a valid one. So this is what is valid here, whereas second one is not valid because it's starting with a digit. So this is not a valid one, and here again this can be valid. Like this you can write. Similarly, if you take this and if you try to provide a space, that may be again wrong. Suppose I take here simple and interest. If I try to write like this is nothing but two words, so it is invalid. I can say this as here invalid. So in this way, you can be defining identifiers. As I told, identifier can be anything, which can be name of variable, it can be the name of the class, it can be the name of say interface, it can be the name of method, or it can be a name of the field within the class. So you can define them like that. They can be called as identifiers. Since you have invented these words, they are called as here identifiers. Okay, and third one is here operators. Operators perform certain operations on the given data. So when you talk about actually any program, particularly computer program, you have data. On the data, certain operations, I mean, they work on the data. So operations, what they do basically, they transform data into some other format that may be meaningful or it may have some semi-meaning. So like that, normally operators can be performing certain operations. Operators means you can be using predefined operators, or even methods can be called as sometimes operations only. Okay, so we have in Java predefined operators. So the operators can be, I mean, different types, like arithmetic you have. Then similarly, you have logical. Then we have relational. Then we have, say, increment, decrement operator, increment and decrement operator. Also we have here conditional operator. Then similarly, we have here bitwise. Okay, so like this, we have different types of operators. So using them, we may be transforming data. We apply the operations on the given data. So operators may be, they may be having only one operand, or they may be having two operands, they may be having three operands, or they may be having more than three operands. So for example, you write here a plus b. When I write a plus b, plus is nothing but an operator. Here it's using the addition operation on both a and b. A is nothing but here an operand, B is also an operand, and this is called as a binary operation. Sometimes what I do, I write minus A. When I write minus A, it's unary because I am having only one operand, that's nothing but A. When I write minus A, it's basically an operation on the one data only. So the operand is only one. So that's why we call it as unary operation. And minus is called as here unary operator. Similarly, you may have something like this, A greater than B. Then you put a question mark. Followed by here, you may write true or you may write here false. Something like this you can be writing. And this is called as here a ternary operator. This is also called as question mark operator because here you have total 3 operands. This is the first operand. Here you are trying to find out the truth value. If A is bigger than B, in such cases that returns a true value. Otherwise, that can be returning a false value. So therefore, we have here 3 parts in this. This is the expression you are trying to evaluate, and this is what here result 1, result 2. If the condition is returning, if it is correct, in that case, this returns true value. Otherwise, it returns false value. So such operands, such operators are called as here ternary operators. So question mark is the only one operator. It is actually ternary operator. And after that, we have one more concept called n-ary operator. So we say it as n-ary operator. This is basically functions or methods. When you write a method, you may be passing number of arguments to that. That is called as actually n-ary operators. So operator is basically perform certain operation on the given data. Even a method can be called as operator. But here, when I talk about arithmetic, logical, relational, increment and decrement, conditional, bitwise, all these are nothing but here predefined operators. If certain predefined operators available in the language, for the intended purpose, you can use. Here similarly, equality operator, inequality operator, shortcut operators. So like that you have so many operators in Java. Very rich in operators. But there is no ambiguity that you have in the C language or in the C++. If you take C++, there is a lot of ambiguity using the operators. Hello, Philip. Any question?
No, I'm fine. I'm listening to what you're saying. I'm just sat here listening.
Okay.
Fine.
So here, there is no such confusion as far as Java is concerned. And n-ary operators, whenever you define any method, probably you pass number of arguments to that method. In such case, we call it as n-ary operators. Similarly, here, another thing what we have is separators. So what is basically separator? A separator can separate. It can be separating, various tokens in the given statement. So with the help of the separators, you can be separating the statements or the tokens within the statement. For example, I write like int a, comma b. So it is separating 2 identifiers. Okay, when I put semicolon, it's going to be here something like C I write. So what it is doing, it is separating 2 statements. Int a comma b is one statement, int c is another statement. So therefore, these can be called as here separators. So we can call like these separators. Comma is a separator, semicolon is also a separator. Sometimes even dot or period also can be a separator. So this is what it is actually a kind of token. One more thing is constants. For example, you take int a equal to I write 100. So 100 is what here? It's a constant. So it's literal. So numeric literal I am writing here. Sometimes I may write like this string str this equal to I write it Java. So this is a string constant. So even 100 is nothing but here a token. This Java is also nothing but a token. So like this, we can be having different types of tokens. With the help of that, you write the code. Philip, any questions?
No, I'm fine. I've seen stuff like this before.
Yes. Am I going fast? Shall I go a little bit slow?
No, you can go a little bit quicker.
Okay, fine. See, since 1995, we had so many versions. Like there are 8 major versions since 1995. Okay, very first version was released in 1995. Since then, we have many revisions to them. Okay, JDK 1.0 in 1996. Initially, in the very first version of Java, there was no JDBC, there were no distributed objects, only simple code you could write. Very simple code, small console applications and Windows applications and applets you could write in the very first version of Java. But now, with the later on in 1996, they released JDK 1.0. In that they introduced actually JDBC and distributed objects. In 1997, they have gone with the new event model. New event model got introduced for actually AWT, Abstract Window Toolkit. With the help of that, you develop Windows-based applications. They were somewhat heavy. So to overcome the problem with the AWT components as well as with the applets, they released actually in 1998 J2EE 1.2. So J2EE stands for Java 2 Standard Edition. Okay, so since 1998, we got actually 3 Java versions: J2EE, J2EE, and one more is J2ME. J2EE stands for Java 2 Standard Edition. J2EE stands for Java 2 Enterprise Edition. And whenever we talk about J2ME, it is actually Java 2 Micro Edition. So it's curtailed version of the J2EE, because J2EE is very big. It is in MBs. Okay, it's in MBs. But in those days, the mobile devices or handheld devices like PDAs, they were not having that much memory. These days we have a lot of memory even in them, but at the time they were not that much powered. So in order to support Java with those things also, they released it very small footprint. So that was with the J2ME, we call it as Java 2 Micro Edition. Mostly in the mobile phones or in the PDS, personal digital assistants, they used it. Okay, so J2EE 1.2, in that they added Swing. Swing is actually lightweight GUI. With the help of Swing, you can develop lightweight, say, GUI applications. It is basically something like window application. So in the Windows application, you have a window, you have a minimize button, maximize button, close button. So such things you can develop with the help of the Swing, and they are very, very lightweight. When compared with the AWT, which was Abstract Window Toolkit, that was heavyweight. Okay, then in 2000, in the J2EE 1.3, they added something clean up. So again in say 2004, they added generics. Like this, actually you have so many versions in the Java. The latest is actually J2EE 8.0, and further latest is Java 9, which is actually being used. But I am using now J2EE 8.0.
Okay.
See, the 5 design principles of Java. It is simple, object-oriented, familiar. So here, simple means easily you can write the code, and as I told, it's object-oriented, and familiar meaning is, see, Java language is similar to C, C++, and even with the JavaScript. If you know those languages, very quickly you can start developing applications in Java, because syntactically it's going to be same. In fact, Java belongs to C family of languages. Most of the programming constructs you have in C, you can have in the Java. Already if you know C and if you know C++, for learning Java it does not take much time, because in the Java you have to learn only things related to object oriented. Already if you know C and C++, so it can be very easy for you. Okay, so if you don't have C++ knowledge, it will take little time to learn Java. So otherwise it should be very fast. And as I told you, it is robust and secure. And one more thing is, it is architecture neutral and portable. Okay, and it's adding the performance, and it is interpreted and dynamic. So these are the 5 design principles of Java. You need any clarification on these?
Sorry, could you say the last word again? Because I heard what you said up to that, and then you just kind of cut out.
Yeah.
Do I?
Interpreted, threaded, and
yeah. Okay.
So interpreted meaning is, so Java initially what we do when we write source code, we translate the right code with the help of Java compiler. Okay. Whenever you are executing Java application on the target machine, it is going to interpreted. And line by line getting executed. So that's the equality of interpreted. And other thing is a multi-threaded. Multi-threaded meaning is, suppose I try to give an example with the MS Word. When you write code, whenever you are working with MS Word, once for every 2 minutes or 3 minutes, automatically it gets saved. Though you don't save it, automatically getting saved. That means what? It has multiple threads. At the same time, many different tasks are going to be working. So you write 1 or 2 lines of code, automatically it may be getting saved if you go with that feature. And similarly, what happens at one end you will be printing, at the other end some other content also you can be adding. So multiple things you are doing at the same time. It's because of actually multiple threads you create. One thread can be working for some time, other thread can be working for other time. See, for example, something like you may be seeing some video from the YouTube. So when you are viewing something that YouTube, what happens? Initially it may be taking little time, but once certain video is downloaded, at one end video plays, at the other end what happens? Video still gets downloaded. So it's happening because of the thread feature. So similar to that, you can develop applications with multi-threading features. With multi-threading features you can be developing. Okay, and you can develop actually dynamic web applications using Java programming language. Not only static, even dynamic applications you can develop with the help of the Java programming language. And the execution also, it has very high performance, but you cannot compare with C++ or C language. So C and C++, they execute 30 or 40 times fast than the Java language. Java applications are very slow when compared with C or C++, but these days there is no problem because you have actually very high-end computers. So it may be very, for end user, it really does not make much difference. So Java applications also, they are running very fast, but they are not super fast like C or C++ applications because they are actually compiled ones, but Java code actually gets executed in the interpreted manner. So definitely Java programs are going to be somewhat slow when compared with the C or C++.
Okay.
Okay. If you look at this, whenever you talk about actually C, basically compared to C, Java is a relatively high-level language with many built-in features for portability, doing useful things such as multi-threading, writing distributed programs, writing GUI clients. Applet is nothing but GUI client, or you may be writing some web page with the help of the JSP. So it's nothing but GUI client. Error handling, extending web servers, embedding programs in web browsers, connecting to commercial databases. So all these are available for us. That means high-level features are available. Programmer need not bother the internal details or intricacies of other application. So without bothering much about that, very quickly you can write. So therefore, Java is very high-level language when compared with the C. Same thing if you have to do with the C, you have to write a lot of code. It is not very easy to write code with the C. You cannot easily create a GUI client. Error handling is also not that easy in the C language. Okay, connecting to commercial database also not that easy as far as C is concerned. But whenever you talk about Java, you have here JDBC. With the help of JDBC, easily you can get connected to commercial databases. Also, you may write some Java program. With the help of that, you can be interacting with server. That you can do with the help of the applet. You have a feature called applet, so that you can embed within the Java browser. So like this, you have many features when compared with the C. But C is C language, no doubt. Very high performance code you can write with the C language, but everything you need to write because this many libraries are not available in C. But in the Java, you have so many predefined things available. With the help of that, very quickly you can develop application. If you are a system programmer, definitely you have to opt C or C++. If you are a high-level application developer, mostly commercial applications when you are developing, so in such cases, you have to choose languages like Java or C#. In whatever you are playing, you can use with the help of that very quickly, rapidly, you can develop applications. But when you develop applications with C or C++, it is not rapid application development. It takes a lot of time to develop code with them. But anyhow, they have advantages. System programming we do with the C and C++, and commercial applications, high-level applications we develop with the help of the Java or using C# or even with the Python. In whatever you are proficient with, that you can develop. Okay. So equally important, Java has many core language features that make it much more natural to express abstraction, develop software frameworks, etc. Also, many core language features which easy debugging and promote reuse. So many of the most of the languages features you can find in the Java language. So this is all related to. I'll be sharing this with you, the PowerPoint presentation. Now I can move into the Eclipse. Have you downloaded JDK, Philip?
Have I? Sorry, what was JDK?
Now, have you downloaded Java Development Kit and Eclipse?
I haven't, no, but I've used it for OSB, I think.
Okay. So you need to download this. And what OS you are using? Is it Windows?
Yeah.
Okay. So Windows 10 or Windows 8 or Windows 7, which client OS you are using for Windows?
I think it was Oracle Service Bus. I think we installed it on 7. Ganesh installed it.
Okay. So you need to, you need to download the JDK. I show you what JDK that is. 1 minute. JDK. You need to go with the JDK. Some otherwise, let me connect to some computer to show you. 1 minute, please.
Okay.
Okay. You have to download this JDK 8U92 Windows x64. This one you need to download.
Okay.
You want to go for just J2SE or J2EE? Which one you try to go through with Java?
I'm not sure yet. I mean, which one would be suitable?
See,
I mean,
J2SE, and second thing is J2EE.
You did say one Enterprise Edition, didn't you?
Yeah, J2SE basically core Java. This is all Java language related features you learn with the J2SE. With J2EE, you work with databases. Okay, with web servers.
I think J2EE probably be more suitable.
Yes, yes. Then other thing is like JSP, and you use Hibernate.
Okay.
You will be using string in this. So, and Java API for XML, you are going to do these things with the J2EE. In the case of J2SE, it is core Java. Only you learn about Java language. So the features of Java. In the case of Java language, so you learn these things, data types. Second thing is like say if condition, then switch case. Then you have switch case. Then similarly you have loops like a while loop, do while. Then similarly it is for loop, for each. These you learn. Apart from this, you learn actually collections. Okay, then it's going to be related to collections you learn, then arrays. In arrays again you have one-dimensional, two-dimensional and variable length arrays. Also it is related to strings, threading. Then you learn actually related to file IO.
I think J2EE is probably better for me because data types, if switch and loops and stuff like that is fairly standard across most programming languages.
Yes.
And I've done C before. It was a long time ago. I used to be a C programmer. I think J2EE would probably be better for me.
Yes. Now in this, there is one extra loop called as for each loop you have. It works over collections, like
Yeah.
arrays or with the collections. In the case of collections, it may be list, array list you have. Okay, then hash table you have, actually stack you have, linked list you have. Those things you have in the collections.
Okay.
Then you have arrays, strings, threading, file IO, and other thing is scanner. So with the help of the scanner class, you can be reading data. You can read data from keyboard. That's called as scanner class. Okay. Similarly, you have here date. Date class is available here. So dates you can manipulate. Simple, text formatter. Simple text formatting also you have here. So simple text format. This class is also available. So these are certain things new to say Java language. These you may not find in you cannot be finding in the C language. Up to loops it's fine. Up to for loop it is fine. Then after this you have to know about classes. Then here objects. Then similarly interfaces. Then inheritance. Okay, polymorphism.
So we're going into object orientated when we say inheritance.
It's object orientation. Yes, yeah. It's object orientation. So these you learn in the J2EE. So once you understand that, you can go with the J2EE. But these things you can learn on your own also. If you just go through this, what are the data types available? What is if condition? What is switch case? What are different loops you have, like while loop, do while, for loop, for each loop, how they work? Okay, then after that, you can continue with collections, arrays, and those things. And even these also will not be taking much time. In 1 or 2 sessions, we can complete these things also. It will not take much time. Since you have experience, so very fast we can complete that.
They're standard functions really across multiple programming languages, really.
Yeah. But just revise, just revision only. Just revision will do. Then very quickly you can be going through that. Fine.
Yeah.
Fine. Then once you finish this, you can look into J2EE. In the J2EE, you'll be getting connected databases. You talk about web servers like Tomcat. Then we talk about JSP. Then Hibernate, Spring, and Jobs. These we cover in the J2EE.
Okay.
Also, you have certain tools like AND tool, AND. Okay. So one more is called as Maven. And apart from this, you are supposed to know so many things like continuous integration, Jenkins. We may not cover Jenkins, but you have to know about the Jenkins also. Okay, Jenkins and GitHub, all these things you have to know. Then in that case, that can be fine for you. So Jenkins is called as continuous integration. GitHub is also nothing but it is a distributed version control mechanism, and it is a build tool. So Maven is what actually POM, project object model. So for project management we use it. So these are related in development. These things are related in development, but and Maven, Jenkins, GitHub. So these two are basically version control, and Maven they are for actually build tools. I can say build on project management tool. For them we can use these.
Okay.
Okay. So like this we'll be covering in this.
Yeah, fine.
So what are your comfortable timings, Philip?
Because I have a very long working day during the week, I can only do weekends.
Only you can attend the weekends.